In how many ways can you integrate cos squared of x? I'm going to do it in a few ways. Let's get started. You can try it yourself if you want to. Obvious way first is to do the standard result, which is to use double angle formulas. So this is the only double angle formula that I remember about cos. And then this I just say is 1 minus cos squared, which makes this minus 1 plus cos squared, which becomes 2 cos squared. Add 1 divided by 2, and then shove this result into here. This is all integrable. This is integrated to a quarter sine 2x plus a half x. And we end up with our constant here at the end, of course, log k. And that is going to be our whole answer. Nice and easy. Next method, we're going to call the integral I, a very standard trick in integration, but we're now going to get out a completely different integral and call it j. This is the integral that's j. And now if we consider what happens if we do I plus j, we're going to get these two integrals added together here. But of course, you can add integrals just underneath one integrand here, so we can just say it's this. But cos squared plus sine squared is 1, and the integral of 1 is x plus some constant. So that's good. And now let's consider I minus j. Because, again, when we bring these underneath the same integral, we just saw this before. This is cos of 2x, which is perfectly integrable. It's half sine 2x with some constant at the end. And then, of course, this is a similar integration now. We're looking for I. So if we add these two things together, we'll get I is this plus that plus some constant. And then, of course, we can divide everything by 2. Sorry, we'll end up with 2i, won't we, because we add them together. And we end up with our answer here, which is very nice. And we'll be done with that as well. Next method, let's consider what happens if we break this cos squared into cos times cos. And now let's do some integral by parts. So let's integrate the one we can integrate a couple of times. So integrate cos to sine a couple of times. So there's integrating. And then take away the integral of, again, we'll keep that sine there. And we'll differentiate this one for minus sine. But that gives you a minus sine times sine, which is sine squared. And of course, these minuses come together for a plus. And by the way, if you haven't seen parts done like that, it's just integrate the one you can integrate a couple of times, or the one that you want to integrate a couple of times. Leave this one alone and then differentiate it, and then just put a minus integral in between. You can do the table with du, dx, and so on. I can dv, du, whatever. I can't be bothered. Anyway, sine squared is 1 minus cos squared. This is the integral of 1 minus the integral of cos squared. But the integral of cos squared is just I. That's the original integral. So we can call that I equals all of this minus I. That should be a dx there, sorry. The integral of 1 is just x. Add I to both sides. Divide everything by 2. Have our constant as well, and we'll end up with the answer here, all good to go. Quite a nice little method. Another one is to do parts differently. We can get out the classic kind of thing that you do if you're integrating log. Just say it's 1 times this, and now let's integrate 1 a couple of times to x and x. Leave this one alone for a cos squared, and then differentiate cos squared for 2 times cos to the power 1 times minus sine, because the derivative of cos is minus sine. Of course, the minuses can come together to make a plus. The 2 can be moved outside. The 1 still integrated to make x here, remember? And now, of course, 2 sine cos is just sine 2x. So we can integrate this by some parts. This time I'll differentiate the x back down to 1, and I'll leave this one alone the first time, but then integrate it to a half cos 2x the second time, or minus half cos 2x, I should say. And I think we'll end up with this. What did I do here? I differentiated this one. Sorry, I integrated this one a couple of times and then left this one alone and then differentiated it over there. That's the method. This all works. This all checks out. I think eventually it works. Anyway, you can write like this, I guess. When that integrates, it goes to that. You have a constant. This is just that. This all checks out. I mean, this is totally the answer. It's all integrated. This totally checks out, though, I think, because cos 2x, as we saw before, is cos squared minus sine squared. So when you take away a half x of that, you end up with a half x cos squared plus a half x sine squared. Cos squared plus sine squared is 1, and that's just a half x. And then we have this, and that was the same answer as we had before. So I think that's all fine and good to go. You could also do integration by triple parts. I've made some videos on that before, where you call this 1 cos and cos, and then you use the integration by parts formula for 3 things. Check that out if you want to. I'm sure you can find some videos on it. Next strategy is to bust out some more complicated integrals. Let's call the integral in cos the nx. And now I'm going to just evaluate this instead, and then just apply it to the case where n is 2. So if I just write this as cos n minus 1 times cos, because of course that makes cos the n, I can then integrate this by parts. Integrate cos because it's easy to integrate. Just integrate it to sine a couple of times. Leave this one alone and then differentiate it over here. You get all of this. Just be careful here. So integrate that to sine, integrate it to sine. That's one of those sines there. Leave this one alone, goes there. And then you take away the integral of differentiate this for an n minus 1 out the front times, and then cos n minus 2. And then the derivative of cos is minus sine, which makes that a plus and makes the extra sign go there. So that's all good to go. Sine squared is just 1 minus cos squared. we can expand this out, and then we can break this integral up into 2 bits like this, I think. Breaking up the integral and then also making this to make sure this happens twice. Now, this by definition is just I when you use n minus 2. So that's in minus 2, and this is just in. But of course, the thing that we were doing originally was in. And now this here is minus nin plus in. The plus i's cancel, and then we can add nin to both sides to get this. And it all looks like this. And this is called a reduction formula. And this is just how we're going to answer the question now. So, of course, I can divide everything by n to end up with this. And now this integral is just what happens when I use n as 2. So let's just put 2's everywhere. And we'll get this. And now all of this is very easy. It's just this. Now, what's I0? Well, I0 is just cos to the power 0 of x integrated. Cos to the power 0 is 1, because anything to the power 0 is 1. The integral of 1 is x plus some constant. So we'll shove that into that result there, and we'll end up with our integral as required. So that was pretty cool. Notice how this is much more powerful than any of the other results, because I can now integrate anything with any number here, right? Like, as long as I think n has to be above 1, right, for the original parts to work. Because I could just use n as 4, or n as 6, or n as 7, or whatever, and I just follow the formula, and you'd have to do it a few times, but it's quite useful. It's called a reduction formula, quite helpful. Anyway, for those who have done complex numbers, e to the I theta is cos theta plus I sine theta. A nice little trick here is if you put in minuses into your theta, so replacing the theta with a minus theta. Cos is an even function, so it absolutely doesn't care when you put the minus here, it's just cos of theta. Sine is an odd function, so it does, but the minus just goes there instead. And now if we add up these two results here, the I sine thetas cancel, and you get this plus this is 2 cos theta, divide by 2 and you get cos theta as this. This is fantastic, because what you'll notice is, 2 squared is 4, so that's a quarter out here, is that when you expand this out, so imagine there's 2 brackets here and do a proper double bracket, you end up with this, I believe, because the powers add together, right? And then when you do the cross terms, these two things cancel for e to the 0, so this just goes away. And there's 2 of them, so it's just 2. And now this is really easy to integrate, because e is really easy to integrate, or e to this something is really easy to integrate. It's just going to be 1 over 2i to the power of the same thing. That integrates to 2x, and that just a minus there, just be careful. And then some constant. Now this is totally the answer because I've done the integrating, so I absolutely don't need to do anything else to this. However, if I were to, I could write this in a very particular way. Let's put these 2 terms together here, and then let's times this term by a quarter to make a half x and just put it on the outside, and then our constant can also sit on the outside over here. And now this result here, if we come back here for a second, and instead of adding these 2 things together, we take them away from each other, we'll end up with 2i sine theta is this minus this, divide by 2i, and you end up with this result here. Now, if you just put 2 theta instead of theta, this just becomes 2i theta minus 2i theta, and that's exactly what's here. So this is here is just sine 2x, and we'll end up with the same result we've ended up with a few times here. The very last result, I think, the very last way of doing this isn't in my PowerPoint, but it is on my computer here. What you do is you Google Wolfram Alpha, and you click it, and this is a very advanced method, just in case you'll get stuck on an integral. You just write integrate, and then the thing that you want to integrate, and bam, there it is. Gives you the answer. Great stuff. Very complicated method. You do only rely on that in exceptional circumstances because it does take a long time to do. And yeah, I'll see you next time.